Hi, my name is Siddhant Iyer, and I am here to present my final report for autonomous trucks and ships for the course Systems Engineering ECEGY 5213 at New York University. Let me give you a quick introduction. As of 2022, self-driving cars are taking over, and researchers believe that the electric and self-driving vehicle industry will keep soaring high and reach an approximate of $186 billion by 2030. Although this seems promising, the bigger picture is not a world with electric vehicles, but a world fully with autonomous vehicles. But to every succession, there are a plethora of challenges to be overcome. Some of the factors that help in booming of these industries are convenience, safety, labor costs, etc. But taking this industry one step further from commercial and applying it to cargo and commodity industry by using autonomous trucks and ships might just change the market space and how things work. Continuous increase in natural gas prices is one of the major point of concerns for the trucking and marine industry, and through autonomous technologies, significant efficiency and safety improvements can be made. This project would seek to check the viability of autonomous trucks and ships, mainly in the transportation industry. And this midterm report discusses different components of system engineering, such as background, concept development, need analysis, concept exploration, concept definition, and the challenges which are faced for this particular project. So let's get a hang of it. Let me give you a background of what exactly we're trying to do. Let's first ask the question, what is systems engineering? Every complex problem or project requires attention to detail and different life cycles, which involves interdisciplinary management of different fields that focuses on main factors such as design, integration, and management. Koziakov and Sweet, in their paper Systems Engineering Principles and Practice in 2003, they define systems engineering as the function to guide the engineering of complex systems. The life cycle of developing any complex project requires defining the customer needs and requirements, and then going into production, system, and validation. System engineering acts as a bridge that connects different disciplines. In this project, we will see how systems engineering helps in the consideration of different disciplines using advanced technology and specialization. Uh, Risk management, integration, verification, and validation are some of the components which are vital for this project. Let's understand the importance of trucks and ships in transportation industry. Trucking industry is a very significant and important subpart of the transportation industry. In 2019, trucking industry on its own comprised of almost 791.7 billion worth of items, and this was 70% of all cargo transportation in the United States. As we know, business and entrepreneurships are like one of the main fundamentals and upcoming industries in every part of the world. And no matter what the size of the business, each and every business depends on trucking industry to transport their products, irrespective of the product size, whether it is small, large, or medium. Uh, while trucks are pretty much the best option for transportation, sometimes it becomes a hassle to transport goods internationally. That is why the ship and the marine industry is the next big thing in the global economy of transportation. On an international scale, transportation uses ships, which comprises of more than 80% of world trade, and it was valued at around 61 billion in 2021. With continuous advancements of technology and ever-increasing rise of e-commerce, trucks and ships are going to be the pinnacle of transportation industry. But there are still a lot of gaps and challenges we face with trucks and ships, and it can be tackled using systems engineering with constant research and integration of different methodology. Let's talk about the rise of autonomous vehicles. There have been a lot of modern technological innovations in the field of science and technology, such as radar, GPS, machine learning and artificial intelligence, computer vision, and so on. Manufacturers are trying to enable self driving capabilities in their vehicles and thus produce autonomous vehicles. There are different levels to autonomy, right from level 1 to level 5. And the higher the level, the more advanced the control system integrated in the car. The autonomous vehicle market is about to blow up soon and is already valued at around $61.93 billion. Even though the COVID 19 pandemic had slowed down and halted the impact of the overall industry, let us see some of the advantages and disadvantages of autonomous vehicles. As you can see on the left side, we have pros, and on the right side, we have cons. Let's go over some pros on autonomous vehicles. Machines don't get tired, so we can carry out transportation exercise 24 hours a day. Robots make fewer mistakes, which leads to less accidents. Systems do not have emotions. No risk of drunk driving, which also reduces accidents. Robots are able to constantly focus, so there won't be any human error, or maybe there will be less error. Self-driving cars follow traffic rules. Robots have higher attention spans. Improvements in mobility for people who can't drive. More convenient driving experience. Potential lower insurance costs. It may be faster on average. It may work while driving possible. Saving on fuel, which is one of the major concerns which was discussed previously. Improvements in air quality, as there won't be any pollution. Reduction in car thefts. Reduction of fatalities due to driver mistakes. And economic advantages. While there are a lot of pros, it comes with a lot of cons. Let us go over some of the cons. Higher unemployment rate, since less cab drivers are needed. It applies for ships as well. There won't be any crew members, so unemployment increases. People may unlearn how to drive manually. Higher congestion levels. High R&D costs and high initial purchase price, which is another point of major concern because autonomous vehicles requires upfront costs. Maintenance may be difficult and it can be costly. There might be privacy concerns. Fun of driving may decrease. Moral concerns will be there, like if people are giving their jobs to machines, what about the future? There might be technical errors. There might be hacking issues and software issues. And bad weather may prevent technical systems to work properly, such as in a storm or in a tsunami. People may not be willing to accept this technology as machines are literally replacing humans. High regulatory restrictions and insurance issues. Let's talk about the first development process, which is concept development. A general life cycle of a complex system usually consists of three major components: concept development, engineering development, and post development. Concept development is one of the most vital steps in a life cycle of a complex problem. This stage requires analysis and planning that are core for establishing a modern system and the viability of its realization of the system architecture. The level of effort is usually less than in subsequent stages. In this stage, establishment, if there is a valid need for a new system, and if the technologically and economically feasible for the market, is taken care of. Uh, Selecting the accurate system concept, defining its functional characteristics, and developing a detailed plan, which may be helpful later during the engineering and post development stages, are some of the few vital features of concept development. The stage of concept development can be broken down into three parts: needs analysis, concept exploration, and concept definition. Let us see one by one what this means. The first component of the concept development stage is need analysis phase. Like for every new system, the question needs to be asked whether a need is there actually, and if there's a pragmatic approach already existing to satisfy such a need. These types of questions are generally addressed in this phase of the concept development. When it comes to trucks, the accident caused by manual mistakes, which leads to deaths and injuries, are soaring high day by day. And research has shown that the trucks are 9 out of 10 times carrying transportation goods and commodities. These type of accidents and safety incidents prevail in the marine industry as well. Every man and crew member at sea are at constant risk and danger of incorrect or ambiguous navigation. This is a constant problem which acts as a marginal hurdle to the transportation industry. Therefore, this leads a need to autonomy in the industry. Auto driving and self driving vehicles help humans with a lot of problems, such as preventing harmful driving behaviors, which include speeding, driving with fatigue, DUIs, etc. It also helps in road safety and prevention of accidents to some extent. Not only this, but autonomical vehicle can also improve the ever-increasing price of natural gas and fuel, and can help save us labor costs as well. Several studies have been conducted to improve the proficiency by reducing the cost of logistic industry. And although the upfront cost of autonomical vehicles are large, the upside is incomparable. And researchers believe that it can bring a widespread impact on the entire industry on a global level. Concept exploration is the second phase of the development stage. The potential of a new system is put into question in this stage and helps us answer the requirement part and help develop the concept with more clarity. Through questioning in the concept exploration phase, valuable and achievable goals can be set for a new system. The main objectives of this phase is to convert operationally oriented view to engineering oriented view. And it generally consists of four stages: operational requirement analysis, performance requirement formulation, implementation of concept exploration, and performance requirement validation. Operational requirement analysis and performance requirement formulation tells us that for this new system, we would require factories with good hardware and software infrastructures, with state-of-the-art technologies such as sensors, which includes LiDAR, radar, and GPS receivers, and such different types of technologies. Along with this, development of algorithms for navigation and autonomous simulations are also a must. Implementation of concept exploration would require then combining and putting together different components of the hardware, software, and algorithms to build and implement autonomy. Performance requirement validation is the last stage of the concept exploration. Various tests have been completed in the past for autonomous trucks and ships, and they have been conducted in this stage of the development. This includes checking the status of infrastructures and facilities to make sure the suitability and compatibility is top notch. And after this phase, we move on to concept definition. Concept definition is the last phase of the concept development life cycle of a new system. In this phase, a variety of alternate system concept needs to be tried out to select the best one, and which constitutes the baseline of development and engineering further. This is the phase where things get real and several competing developers have to multiply their efforts to achieve desired functional and physical performance in a new system. Several issues and obstacles will need to be tackled in this phase, such as risk assessment, test and feedback procedures, performance versus cost trade-off estimations, and so on. It will help to develop and authenticate autonomous trucks and ships. Now let us talk about the second stage in the life cycle of a complex system, which is the engineering development. Engineering development comes before post-development and is after concept development. The main focus is on designing, building, and testing the system to ensure that it meets the requirements and specifications established during the concept development stage. It generally comprises of three components: advanced development, engineering design, and integration and evaluation. Advanced development is the first phase of engineering development. It consists of requirement analysis and prototyping. The main objective is to solve majority of uncertainties that occurs in the project. This can be done using assessment and development to authenticate the system design. This is the phase before the engineering design. Requirement analysis for advanced development. To perform a requirement analysis for autonomous ships and trucks, you will need to consider a diversity of factors, including the intended use of the autonomous technology, the operational environment, the required level of autonomy, the capabilities and limitations of the technology, and any relevant regulatory or legal considerations. Some specific elements to consider when performing an requirement analysis for autonomous ships and trucks include the purpose of the autonomous technology. What task will the autonomous technology be used for? Will it be used for navigation, propulsion, cargo handling, or some other function? Understanding the intended use of the autonomous technology will help to determine the specific requirements that must be met. Second is the operational environment. Where will the autonomous technology be used? Will it be used in open waters, in port, in shallow waters, or in some other environment? Understanding the operational environment will help to determine the requirements for sensors, communication systems, and other technology that may be needed to support the autonomous system. Third is the required level of autonomy. How autonomous does the system need to be? Will it be required to operate completely independent, or will it be needed to operate it by human in some situations? Understanding the required level of autonomy will help to determine the complexity and sophistication of the technology that will be needed. Fourth, the capabilities and limitations of that technology. What is the current state of the art in autonomous technology, and what are the limitations of that technology? Understanding the capabilities and limitations of the technology will help to determine the requirements that can be realistically met. And finally, the regulatory and legal considerations. Are there any legal requirements that must be met in order to use autonomous technology? And understanding these requirements will be essential in ensuring that the autonomous system complies with all relevant laws and regulations. By considering these and other factors, we can develop a comprehensive understanding of the requirements for autonomous ships and trucks, which will be critical in ensuring that the technology is safe, reliable, and effective in meeting the needs of the users. Now let's look over prototyping. Prototyping is the process of creating a physical or functional model of a proposed design in order to test and refine that design. Prototyping is an important step in the development process for autonomous ships and trucks, as it allows developers to test and validate the functionality and performance of their designs before they are built at full scale. There are a variety of approaches to prototyping that can be used in development of autonomous ships and trucks. Physical prototypes. Physical prototypes are physical models of the autonomous ships or trucks that are built using materials such as metal, plastic, or wood. It can be used to test the mechanical and structural aspects of the design, as well as the overall form and fit of the vehicle. Second is the functional prototypes. Functional prototypes are functional models of the autonomous ships and trucks that are built using the same technologies and components that will be used in the final product. They can be used to test the performance and functionality of the system, including the sensors, communication systems, and control algorithms. Virtual prototypes. Virtual prototypes are digital models of the autonomous ships or trucks that are created using computer-aided design, also known as CAD software. It can be used to design and performance of a vehicle in a virtual environment without the need for physical prototypes. And finally, hybrid prototypes. Hybrid prototypes are a combination of physical and virtual prototypes that can be used to test both the mechanical and functional aspects of the design. It may include both physical and virtual components and can be used for the integration of those components. Here is an example of what prototyping looks like. This is a prototype of an autonomous ship that was created. Now let's look over engineering design, which is the second phase of engineering development. This is the process of creating a plan or specification for the creation of modification of a system or product. The main objective is to identify the needs and requirements of the systems, develop potential solutions, and create detailed plans and specifications for building the systems. It is an essential part as it helps to ensure the final system's reliability and maintainability. Let's look over reliability. System reliability refers to the ability of a system, such as the autonomous truck or ship, to perform its intended functions consistently without failure over a specified period of time. In the context of autonomous trucks and ships, reliability is an important factor to consider, as these vehicles are often required to operate over long distances and in a variety of conditions. Let us look at some of the factors that can affect reliability of an autonomous truck or ship. This includes the quality and reliability of the components the system is using, the design of the vehicle and its system, including the redundancy and fail-safe features built into the design, the operational environment, including the conditions in which the vehicle is expected to operate, the maintenance and upkeep of the vehicle, including regular inspections and repairs as needed. To ensure the reliability of an autonomous truck or ship, it is important to carefully consider these and other factors during the design and development process, and to implement robust testing and validation procedures to ensure that the vehicle is safe and reliable before it is put into operation. Ongoing maintenance and monitoring of the vehicle can also be held to ensure that it continues to operate reliably over time. Next, let us look at maintainability. Maintainability refers to the ability of a system to be easily maintained and repaired when needed. Maintainability is an important consideration in the design and operation of autonomous ships and trucks, as these vehicles are often required to operate over long distances. There are a number of factors that can affect the maintainability of an autonomous ship or truck, including the design of the vehicle and its systems, the use of modular components and easy to access service points, the use of standard and widely available components which can make it easier to find replacement or spare parts when needed, the availability of diagnostic tools and documentation which can help maintenance personnel quickly and accurately identify and fix the problem, the training and expertise of the maintenance personnel, including their familiarity with the vehicle and its systems. It is important to carefully consider these and other factors during the design and development process in engineering development, and to implement robust maintenance and repair procedures to ensure that the vehicle can be easily and effectively maintained over time. Let us look over integration and evaluation, which is the third phase of the engineering development. The main process is to bring together all components and systems of an autonomous truck or ship and test them to ensure that the function is doing as intended. The main objective is to ensure that the vehicle is safe, reliable, and effective in meeting the needs of the users. There are several steps involved in the integration and evaluation process for autonomous trucks and ships, including assembling the vehicle. The first step in the integration and evaluation process is to assemble the vehicle, bringing together all components and systems that will be used in the final product. Second is testing individual components and systems, which is also called as unit testing. Once the vehicle has been assembled, the next step is to test the individual components and systems to ensure that the functions are doing as intended. This may include testing sensors, communication systems, control algorithms, and other technology. Integration testing. After the individual components and systems have been tested, the next step is to test the integration of these components. This may involve testing the communication and interaction between different systems, as well as the overall functionality of the vehicle. System level testing. After the integration testing is complete, the next step is to conduct system level testing to ensure that the vehicle functions as intended in a variety of scenarios and conditions. This may include testing the vehicle in a simulated environment, as well as in real-world conditions. And finally, evaluation and refinement. Once the system testing is complete, the final step is to evaluate the performance of the vehicle and make any necessary refinements to improve its functionality and reliability. By following these steps, developers can ensure that the autonomous truck or ship is safe, reliable, and effective in meeting the needs of the users. Now let us look over the third and final stage in the life cycle of a complex system, which is the post-development stage. It comes after engineering development. This phase typically includes activities related to the deployment, operation, and maintenance of the system, as well as any necessary updates or modifications. It generally comprises of two components: production and deployment, and operation and support. Let us look over the first component, which is production and deployment. In the post-development stage of an autonomous ship or truck, production refers to the process of building and delivering the vehicle to its intended users. This process typically involves activities such as assembling the vehicle, testing it to ensure that it meets the required specification, and delivering it to the consumer. Some specific elements to consider when planning for development of autonomous ships and trucks include production facilities. To produce autonomous ships and trucks, you will need to have appropriate production facilities in place. These facilities should be equipped with the necessary tools and equipments to assemble and test the vehicle, as well as necessary support systems such as power and water. Production processes. You will need to develop and implement production processes that are efficient and effective in building the autonomous vehicle. This may involve identifying and procuring the necessary materials and components, assembling the vehicles, and testing them to make certain that they require specified quality control. To ensure the reliability and performance of the autonomous vehicles, it is important to implement robust quality control processes. This may involve testing the vehicles at various stages of the production process to ensure that they meet the required standard, as well as conducting inspections and audits to verify the quality of the finished product. And finally, the delivery. Once the autonomous vehicles are built and tested, the next step is to deliver them to the customer. This may involve arranging for transportation and logistics, as well as any necessary documentation or paperwork. By carefully planning and executing these and other production activities, we can ensure that the autonomous ships and trucks are built to required standards and delivered to a customer in a timely and effective manner. Let us look over the second component, which is operation and support. Operation and support refers to the activities that are necessary to ensure that the vehicle is able to operate safely and effectively over the long term. This may include tasks such as monitoring the vehicle performance, providing maintenance and repair service, and updating or modifying the vehicle as and when needed. Some specific elements to consider when planning for operation and support of autonomous ships and trucks may include 1. Monitoring. To ensure the safety and reliability of autonomous vehicles, it is important to monitor their performance on an ongoing basis. This may involve collecting data from the vehicles, analyzing the data to identify any issues or trends, and taking action to address any problems that are identified. Maintenance and repair. To ensure that the autonomous vehicles are able to operate reliably over the long term, it is important to implement a robust maintenance and repair program. This may involve tasks such as inspecting and cleaning the vehicles on a regular basis, replacing worn or damaged components, and performing any necessary repairs or upgrades. Third, modification and update. As the autonomous vehicles operate, it may be necessary to make updates or modifications to improve their performance or address any issues that arise. This may involve updating software or firmware, adding new components or systems, or making changes to the vehicle's design. And finally, support. To ensure that the vehicles are able to operate effectively, it may be necessary to provide support to the users of the vehicles. This may involve tasks such as providing training, documentation, or technical support to help the users understand and operate the vehicles effectively. By carefully planning and executing these and other operation and support activities, we can ensure that the autonomous ships and trucks are able to operate safely and reliably over the long term. Let's talk about some challenges which comes with autonomous vehicles. There is without a doubt a challenge of unemployment as putting truck drivers and ship crew out of jobs because of no humans which will be involved. Not only materialistic but corporal damage is also another major concern, such as damage of goods, no one to take care of, no supervisors. There are also legal risks to it, like there are no rules and regulations or a particular law or a constitution followed, or it has not been implemented yet for autonomous vehicle. And there are a lot of technological risks as well, such as hacking and networking issues, which we spoke in cons for autonomous vehicles. And it includes like networking issues such as during bad weather conditions such as storms, tsunamis, etc. But as we get deeper into the project, we should learn what are the potential challenges can this type of system face. Here are the references which have been used for this particular project. system development process by Kosiakov and Sweet in the first link. And the impact of autonomous ships on safety at sea was another article which was used to estimate the number of people working in at sea and what are the potential challenges faced by them. Let us take a look of an example of autonomous trucks which have been implemented by Loblaw for delivery system.
You're not seeing things. This delivery truck is driving without a human behind the wheel. Loblaw has 5 self-driving trucks hitting the roads in and around Toronto, but they won't be coming to your front door. They'll only be used between the warehouse and some stores.
It's a bit more manageable because you're going on a fixed route between locations that you know.
The pilot project started back in 2020 with someone in the driver's seat for safety. Since then, they say there have been no accidents.
We have multiple different sensors on the truck, so multiple LiDARs, multiple cameras, multiple radars as well.
Regulators gave the green light. Now the safety driver has moved to the passenger seat and could be removed entirely in the coming months. Gatik, the U.S. startup developing the technology, predicts driverless trucks will be 30% cheaper than regular ones.
To address the driver shortage and meet the demands of the end consumer, this kind of technology, this kind of solution is very critical.
There are 30,000 open jobs for truck drivers in Canada right now. A spokesperson for the Canadian Trucking Alliance tells CBC News they don't see this technology taking away jobs, just changing them.
We should be able to use this technology in those cases that we are definitely short in human activity and manpower.
Experts say while going driverless works for some parts of the supply chain, like highway transportation, neighborhood streets aren't ready.
It should be a long, long time. I don't think that we have any breakthrough on somehow replicating human brain and the way that we think and do judgment. I don't think that we are there.
Still, these driverless deliveries mean the technology is accelerating. And for those on the road, seeing that empty driver's seat may take some getting used to. Nisha Patel, CBC News, Toronto.
That's about it. Thank you so much for listening to all of it. And as the project continues, there will be a lot of new research and development, which I will update on. And yeah, have a nice day and see you soon.